Okay, this is section 2.6, the distributive property. Our goals for today, I want you to be able to use the distributive property, and I also want you to be able to simplify expressions by combining like terms. So first, let's take a little quick peek back to section 2.3. If I have 9x minus 3 and I want to know what the terms are, so the terms of 9x minus 3 are 9x and negative 3. Now let's look at a few examples of some terms. I could have x, 8a, just a plain old 5, 3xy, or even 5 times a divided by 3. Those are all examples of terms. So anything connected by multiplication or division is considered one term. So anything connected by multiplication or division is considered one term. And our terms are always going to be separated by addition or subtraction signs. Now there's some more terminology that we need to know. We need to know what a coefficient is. And the coefficient is the number that's in front of the variable. And that number is multiplied by the variable in the term. So a coefficient is the number in front of the variable. So if I have 6x, my coefficient is 6. If I have negative 3x squared, my coefficient is negative 3. If I have negative x, my coefficient is negative 1. If I have y, my coefficient is 1. Now another thing we need to be comfortable with are like terms. Now like terms have the same variable raised to the same power. Okay, so some examples of like terms. Well, let's look and decide if these are like terms or not. If I have 2a and 3a, are those like terms? I'm going to look at the variable. I have a regular a, no exponent. Yes, those are like terms. Now if I have 3xy and 3x squared y, are those like terms? Well, let's look. xy, oh, x squared y. I've got an exponent over here that I don't. So those are not like terms. Now let's see. I have 2xy and 6yx. Are these like terms? Well, let's take a look. xy, yx. Well, they're just in a different order. So yes, these are like terms. Now these are using one of the properties of multiplication. The commutative property. The order that I multiply doesn't matter. So x times y is the same thing as y times x. A better form would be to make sure I had them both in the same order, so 2xy and 6xy would make more sense to us. Now let's see, what if I have negative 4a squared and 9a squared b? Oh, I've got a squared and a squared. Oh, but these are all multiplied together, so that's one term. This one doesn't have a b. So these are not like terms. Now the reason it's important to be able to recognize like terms is if I have like terms, they can be added or subtracted. That's the reason it's so important. Okay, so let's take a look at a few examples. So our directions say to simplify. Okay, the first one I have 2a plus 3a. Check to see if I have like terms. I have a. Okay, now I'm going to combine my coefficients using the rules of addition. Okay, 2 and 3, same sign. Add and keep the sign, so I get 5a. The next one I have negative 5y plus 3y. Have the same variable raised to the same power. My signs are different. I'm going to take the small number from the large number, keep the sign of the large. So 5 minus 3 is 2, so I know that's negative 2y. Notice that nothing is happening to my variable. It's staying the same. 3ab squared minus 5ab squared. Same variables to the same power. 3 minus 5 is going to give me a negative 2ab squared. Negative 10c plus 10c. Well, opposite signs. Negative 10 plus 10, oh, that's 0. If I have 10 things and I take 10 things away, I have nothing. Or if I owe you $10 and you pay me $10, then you owe me nothing. Okay, now let's go ahead and use the distributive property. Now look right here. We have 2 times x plus 5. Notice that this 2 is right outside the parentheses. There's no addition, subtraction sign right there. That's how I know I need to multiply. So I'm going to distribute. Now when I distribute, it's just like if I'm handing out candy. I have to share with everybody. 2 times x gives me 2x. 2 times 5 gives me a positive 10, so I'm going to write plus 10. Now b is going to work exactly the same way. I'm just multiplying from the other side. The number that I'm multiplying by is behind it, and that's okay. So negative 3 times 4 gives me negative 12. Negative 3 times x gives me a negative 3x. But we have a proper form in math when we write these equations, or write these expressions, I should say. We always want the number with the variable to go first. So I'm going to move my negative 3x to the front, my negative 12 to the back, and that's going to be our proper form. Negative 12 minus 3x is correct. We just want to make it a little better by putting it in the right form. It's just like writing a sentence in English. There's a proper structure for the sentence. You begin with a capital letter, you end with a period. We're doing the same thing in algebra. Y times 1 gives me y. Y times negative y gives me positive times a negative, negative y squared. Because remember earlier, if we multiplied x times x, that's the same thing as x squared. We just don't want to have to rewrite x times x, so that's our shorthand. Now on D, we've got something a little extra. This 3 is kind of tagging along. So we're going to go ahead and just bring it down first. I'm going to call it like your little brother, your little sister. You don't want to forget them. They've got to tag along, and that's okay. They're just going to watch you and your friends hang out. So we have negative 2 times 4, so it's going to give me a negative 8. So it's going to kind of turn in my sentence, my algebraic sentence, negative minus 8. Negative 2 times x, negative 2x. Now, really important, I have to go and I have to combine my like terms. Well, I don't have anything that has an x, but I have 3 minus 8. Now, what's 3 minus 8? Small number from the large, keep the sign of the large. That gives me negative 5 minus 2x. We want to make sure our form is good, so we're going to write it as negative 2x minus 5. Okay, now we have 3 minus 2 times 4 plus x. So once again, we don't want to forget our little brother or sister, so we're going to go ahead and bring them down. Oops, we just did that one. Let's move on to the next one. So here we have negative 2 minus x plus 5. We're going to bring our negative 2 down because there's nothing I can do with it. Now remember, I always tell you math people kind of leave out things when we can. There's really a 1 right inside of there. That's going to help you when you distribute. So now I'm distributing a negative 1 to each term. So I have negative x now. Then a negative 1 times a positive 5 gives me a negative 5. I'm going to combine my like terms. I have a negative 2 and a negative 5. Signs are the same, so I'm going to add and keep the sign. So now I have negative 7 minus x, but I want to make sure I put it in my best form possible. So I'm going to write it as negative x minus 7. Okay, last problem. Now I have 3t times t. It's going to give me 3t squared. 3t times negative 5 is going to give me a negative 15t. Then I can't forget my little brother or sister, so I've got to bring that down, so plus 6t squared. Now I'm going to go through and I'm going to combine my like terms. I have 3t squared and positive 6t squared. Add my coefficients, so I have 9t squared minus 15t. And that's it.